Hey everyone, welcome to my YouTube channel. So I'm Group 5 Navigator Bridget. Still continuing with our project of layer-wise backward propagation for detecting and reconstruction of real faces from FEP. So about our midterm, we to implement a Menlo flow in our project. So the tools selected was Zen Machine Learning MLflow. That's basically for deployment, service connector, tracking, and then data version control. And then you also choose the data version control itself. That's for with the GitHub repo for committing changes, any changes that are made to the system will be committed there. And then the roles of MLflow. One is experiment tracking. It tracks the experiments worked on, like including the model configurations, hyperparameters, and evaluation matrices used, like F1 score, talk of precisions, and so on. And then model tracking and versioning. This ensures reproducibility and enables you to easily deploy and reproduce models in production. So it basically helps you to deploy your work on time and every time. Artifact logging. This provides a centralized location for storing and accessing experiment artifacts, making it easier to share and collaborate with members. The member can access it anytime from anywhere. And then model deployment. This allows one to deploy trained models for inference in protection environment. And then also the roles of the data version control. The basic first role is data versioning itself. So this helps version control. DVC helps version control the datasets, ensuring producibility and tracking changes over time. So it controls the changes in datasets. That's it basically. And then data pipeline management. DVC allows you to define and manage data pipelines, which are sequences of data preprocessing steps. These are basically steps that you go through to produce data and maybe deploy a model. And then data reproducibility. DVC ensures that your experiments are reproducible by linking data sets to specific versions of your code and model. And then collaboration and sharing. DVC facilitates collaboration among team members by providing a centralized repository for data sets and basically provides an environment for everyone to deploy their work, and then maybe also in case of comparisons with another colleague's work, you can get it from there. And then yeah, finally we'll go to the code, the steps, the key steps and highlights from the hands-on task. So basically, first of all, I have to create a bucket from Google Console for the storage, where you first name your bucket. You name the bucket like get started real fast, and then like where you going to store your data, the location, maybe can be multiple regions. You can say in the United States, and then also location type can also be multiple regions, and then default storage class. And default storage class, we took it has to be standard, basically meaning it has to be obviously the one used. So for the case of access control, we have uniform and fine grained. So in this case, we basically choose the uniform because it ensures uniform access to all objects in a bucket by using only bucket level permissions. And then this option also becomes permanent after 90 days. Okay. So you have key steps and highlights from the handout task. Well, this is the Zenmail account for pipeline and team collaboration. So you got this message of congratulations with just training your first ML pipelines. So that part we chose how to protect the data, soft release policy. So anybody was object visioning that was disabled, object retention policy also disabled, object retention, encryption type, that was from Google Managed, that was basically Google Managed. And then you can also grant permissions to bucket get started real faces. For other collaboration, you can say, I've granted permission to, let me say Navigator Bridget at gmail.com. You also set up the backend for a notebook and start the MLflow. You can start the MLflow run from that notebook. So yeah, that's how we managed to run the first MLflow. And then So for the code pipeline, this is it. Basically, you can, if you see clearly under the code, we're just basically training a model whereby the definition says div train fake detection. So pipeline is training the model for fake. This is basically for the fake image. So the data, you train the data also, you learn the data you're going to use, and then you run it afterwards. Yeah, this was the data used, that were categories, they're training the fake and also training the real. And still the arrangement, that's the arrangement of files. Well, we imported it, but we used some, we were coding all this in the notebook. So the beginning of the notebook and the code of the MFlow code, such as we use the MFlow start run, then share all look at the matrices and visualization, then get ZenML accounts and create pipelines, and then we get services and visualize the work on the dashboard. You also install ZenML and so on and so on. Yeah, so basically that was it under that code. This was basically just the arrangement of files and various. Then runs and visualizations. How we run the code and visualize this. Basically here we're training the model, like the input and what can output. As we saw the error message here, first of all, we went to image. We get the data. We also used images and labels. And so if the image is none or label is none, if there is no image or label, the data, the model will turn an error message like images or labels are missing from the data dictionary, or else it returns true. And then this was the dashboard for ZenML. This is how it appears. And then the pipeline, this was the pipeline created in ZenML, in machine learning. So the first best way to enable Google Cloud Storage API, you create a service account, you can generate a JSON key for the service account, and then manage service accounts, you can configure bucket permissions, configure the bucket backend and cloud storage. You can also use GitHub, then you use GitHub to upload the code, confirm ZenML clouds for pipeline, deployment tracking, and collaboration with other colleagues. So yeah, just basically pipeline where we got the data, we load the data, and then the data set, we then split it into raw data set and raw data set test, and then raw data set tray to be trained, and then we continue to the data preprocessor where we look where under data set training, we train the model, and then we evaluate the model and under. And then on a pre-processing pipeline, we just get the data set and apply it. And then for deployment of models, we get repo cloning. This is it. And then so the challenges encountered and how they were solved. First of all, learning curves. Each of these tools has its own learning curve, and team members may need time to become familiar with these concepts, workflow, and APIs needed so as to apply the effects on this code. And then to capabilities, ensuring capability and similar integration between different tools can also be challenging, especially if they are built on different frameworks or having conflicting dependencies. And infrastructure setup. So setting up the infrastructure to support these tools, like the deploying ML flows, tracking services, configuration, device repositories, and setup, is also somehow complex and time consuming since it takes since you need to understand each step and you have to give it enough time to understand. And then data management, managing data versioning, lineage, and storage can also be challenging since the data is too much and it's hard to control its version. And then the solution that we applied, we had to ensure adequate training and documentation, and then capability checks and testing. So the impacts of MOps on our project were collaboration and reproducibility. It helps us in model tracking, model reproducibility, model deployment, and then model monitoring and performance. That's it. Thanks for listening.